What if the ground beneath every road, parking lot, and foundation could be made stronger than the materials built on top of it? What if the soil already there was not your greatest liability, but the very thing you built on? Take this fine sand from Buckeye, Arizona. In the field, it behaves like powder. It shifts underfoot, it won't hold a shape, and it offers nothing to build on. Certified labs gave it an AASHTO rating of non-plastic with 0% plasticity, meaning it has zero cohesion and absolutely no structural integrity. Engineers reject this material by default. It's considered completely unusable. The old way accepts the verdict. The new way puts it to the test. We treated the sand with in place and put it to the industry standard Marshall test, which measures a material's resistance to heavy loads. The minimum passing threshold for road-based qualification is a score of 35. This unusable sand tested at 38 after treatment. A material with zero inherent structural value now exceeds the standard for road construction. Most soil problems are actually molecular problems. The particles will not bond together, so the ground will not hold a load. In-place BaseGrade solves that at the source. Its macromolecular formula permanently cross-links soil particles, transforming any native material into a cohesive, load-bearing structural base. It works with any soil type and any existing material already on site, including native soils, recycled asphalt millings, and mixed aggregates. No excavation, no imported fill, no specialty equipment, no heat. What was previously considered unusable ground became the foundation itself. Those results are not a demonstration in isolation. They are verified by laboratories holding AASHTO accreditations and U.S. Army Corps of Engineers qualifications, the exact standards used by State Department of Transportations. In Cerro Colorado, Peru, a test road was treated just 4 inches deep. The project required a passing grade on the worldwide standard engineers use to certify whether ground can actually bear heavy traffic loads over time. That standard is called CBR, and a score of 100% is a demanding threshold. After treatment, the subbase reached an unprecedented 125% CBR. Then came the real test. The treated base was left completely exposed for 5 months of Peru's torrential rainy season with no asphalt or cover of any kind. After those 5 months of exposure, a 2-inch wear course of asphalt was finally installed. 1 year later, it was carrying over 4,000 vehicles a day through seasonal flooding. 5 years later, we went back. Just 30 feet away, an untreated section of the very same road tells the full story of foundation failure. Extensive pattern cracking, deep recurring potholes, the same climate, the same traffic, the same environment. The only variable was what was done below the surface. We walked the entire treated section looking for the worst damage we could find. What we found was this: a single superficial crack in the top asphalt layer. No structural deterioration, no reflection, cracking from below. The foundation underneath remains perfectly intact. The old way creates strength through rigidity. It forms a brittle matrix. When the ground shifts, it fractures, and those cracks reflect right up to the surface. In place does it differently. Rather than locking the soil into brittle structures, it binds the particles together in a way that allows the ground to absorb a load and return to form. When compared to all other products on the market, In Place builds a structural base from any soil type, without the strict application restrictions and material limitations that hold the old way back. To understand why this matters, you have to look at how roads actually fail. 78% of road failures originate in the foundation, not the surface. Every time a vehicle passes over an insufficient base deflects, the surface above cracks, so crews patch it or apply an overlay. But because the repair never fixes the weak foundation, the base deflects again. The patch fails, and the road continuously gets worse. You cannot fix a foundation problem from the surface down. Every dollar invested in the subgrade saves $4 to $7 across every layer above it over the lifespan of the road. Let's look at an example with full-depth reclamation. Here, we see a completely failed road. The existing asphalt is broken up. It's milled down. The broken surface and underlying soil are mixed together into a single homogeneous blend. That blend is then sprayed within place. The solution penetrates the material. The treated blend is graded to spec and then compacted. Within 24 hours, this base is ready for a wear course. If your road was never paved to begin with, the same equipment and the same process requires fewer steps, not more. There is no failed surface to reclaim. You treat the native soil that is already there, graded and compacted. Same result, simpler execution. And because the foundation is now genuinely load-bearing, the wear course above it can be dramatically thinner. For local and rural roads, chip seal alone is often sufficient. Where asphalt is required, a road that previously needed 4 inches can now be built with as little as 1.5 inches. That's not a minor material savings. Across a county road program or a multi-mile rural project, that reduction in asphalt thickness changes the entire economics of the job. The same principle applies at the other end of the spectrum. On major highway and interstate construction, a treated base behaves like a flexible platform rather than a rigid slab. That changes the structural math for everything above it. Engineers can specify less rebar, thinner concrete, and a reduced wear course. In place applied to the base course is what makes the recalculation possible, and the savings compound across every layer above. In South Bend, Indiana, a 1-mile reclamation project using this exact process was ready for chip seal within 24 hours of treatment. The entire project, start to finish, was complete in 2 days. The old way means excavating the failed base, hauling it out, sourcing and transporting premium aggregates, and rebuilding from the ground up. Specialty contractors and asphalt plants, hot mixed logistics, weeks of road closure, aggregate haul trucks creating liability on public roads. The new way means the road crew already on site finishes in 2 days, using the material already there with equipment they already have. This brings us to a critical distinction. The failure cycle that drives conventional maintenance costs is addressed at the source. Second, when that road eventually does need attention, the base can be reclaimed and retreated using the material already on site. No excavation, no imported aggregate, no landfill. The same crew, the same equipment, the same process, rebuilt in place. Your road is no longer a depreciating asset requiring periodic replacement. It's a renewable infrastructure system, and the ground it is built on never leaves the site. In Place carries a 0 VOC rating. In practical terms, that means no hazmat protocols, no regulatory flags, and no site restrictions based on chemical exposure. You can handle it barehanded in the field. It cleans up with water. The ecological testing goes further than most products in this category, with independent laboratory testing confirming it is safe for aquatic species, safe for soil ecology, and safe for groundwater. It meets and exceeds standard environmental thresholds at every level of testing. Other products in this space do not have that record. Now, look at this project in Prescott, Arizona. In Place was cold applied with 0 specialty equipment, and workers applied it in normal field clothing. That road has recorded 0 maintenance for 18 years. Not reduced maintenance, but none. Here in this AASHTO certified lab, you can see In Place diluted at a 1:4 ratio with water and mixed until the solution turns cloudy, which confirms full dispersion of the formula. At Magic Mountain, California, the project used ABC aggregate, a mixed soil type that can be problematic for conventional stabilizers. The project utilized 100% existing on-site material. A single 250-gallon tote was mixed directly into standard water truck. The ground was scarified. The In Place solution was sprayed onto the scarified surface. The soils were blended with equipment already on hand. The base was then compacted to 98% density. The leftover solution was then sprayed superficially for dust control. You can see here where untreated ground allows dust to move freely. When treated, there is 0 dust movement. This is a minor demonstration. A more dramatic view comes from this helicopter flyover, where you can clearly see the boundary between treated and untreated ground and the complete absence of dust movement from the treated area. This capacity for dust control has allowed mining and construction projects to restart in regions previously shut down by air toxicity complaints. In Place BaseGrade changes the equation at every level. Roads are built faster, last longer, and cost less. Projects previously prevented by poor soil conditions can now be built. This is not an incremental improvement on the old way, and it does not require learning new skills or bringing in new equipment. The crews and machinery already on site do the work, with less labor, less equipment, and less complexity than the conventional approach. The crews are safer, the surrounding environment is safer, and the roads they build perform better and longer for the communities that depend on them. To see what in-place BaseGrade can do for your specific project, reach out to us at the link below. The ground beneath your project is no longer your greatest liability, it is your greatest asset.